Hello and welcome to my lesson on statistics 1, in which I want to show you some two concepts only, and I hope they're going to be helpful for you. And I think we should start right away. Now, the objectives of this particular lesson is I wish that a person who goes through this tutorial should be able to create a frequency distribution table from some given data. The person should also be able to draw a histogram from the given data and use it to estimate a median correctly. Those are the only concepts that I'm going to show you how to develop the frequency distribution table from given data, and again how to draw histogram from given data and how to use it to estimate median correctly. And so let's begin. Now I'm going to take you through the concept by using an example, and the question is given there. So the data we're given is about the number of passengers in a certain regular weekday train service of 50 occasions. And so there it is. What this data really means is in a certain regular weekly train service, in one of the days it was recorded that there were 165 people in that particular train. Another day there was 177. Another day had 160 people in the train. Another day had 171. Another day had 210. And so all of these figures really mean the number of people or passengers that were there in that particular train on that particular time. And so the times that it was tested, it was 50 times, and they are the ones that are recorded there. So the question is, reduce this data to a grouped frequency table with class intervals of 10, starting with 10, etc, etc. So I'm going to take you through that. Another question you asked is, you use the data in the frequency table to estimate the mean number of passengers on the particular occasion, and also estimate the range of values in the B to 80% of the class. And so let's begin with developing the frequency distribution table. Now, as we begin, I need to mention this, that first of all, the frequency distribution table has 3 columns. We have classes, all right? We also have tallies. We also have frequencies. Those are the 3 columns that must be there in the frequency distribution table. And I need to mention another concept or another point there, that we use class boundaries, not class limits. And that's really vital, because take for example, if you are having the classes being say 110 to 120, then 120 to 130, 130 to 140, would all of us would have values here as 110, 120, 130 up to 210. Would also have 120, 130, 140, 150, that way up to 220. And if you look at the data that are given, there's a place we're given, say like 130. So we would not be sure where to place that particular number, because is it in the 120 to 130, or is it between 130 and 140? So to reduce or to eliminate that kind of confusion, we use the class boundaries, not limits. These are boundaries, not limits. Limits are the kind where the value that ends here is the one that begins here, or the value that ends here is the value that begins here. And so that point should really be taken with great seriousness. Now, how do we develop this? I want to take you through that, and let me say this. We normally let me pick a pen here and take you through. Yes, we normally strike these numbers this particular way. To tally, we normally have say 165, you strike it, and because it is between 160 and 169, you put a stroke in that place. Again, you go to 177, you strike it. It is between 170 to 179, so you strike that way. We have 160, that's that one there. You strike again 160 to 169. Okay, you go again back there to 171, and where is that? It is in this particular second class here. Coincidentally, we've just been operating in 2 classes. Here we go to another one. Here you can see we have 210, and so 210 is the last class. You see what I'm doing? We first of all strike here and ensure we record it by striking again. And when you have struck say 5 times, so if that is a third and that's the 4th, the 5th time we normally bind it that particular way, so that they are easy to count, so that we know that when it's bound that way, we know there are 5. If they're bound that way and then we have say 2 other strikes, it is easy to notice that this is just 7, even without having to calculate. If we are having say one recorded say that way. Those are two bundles, and say 1. We know that that's 11 even without counting, because we know this is 5 plus 1. So basically follow that order. Now the alternative that students normally use, which I think is not right, is this kind of a thing, and let me explain. And maybe I need to wrap those ones, so let me erase them. Yes, let's remove all of those values. Let's remove those values. Yes, and even these ones here. Good. Now I have seen students do this, and I want to caution you against it. And so don't do this. There are students who do it this way. They look for, because the first class is 110 to 119, they look for where is a number that's between 110 and 119. So they move all the way, and where's the first one now? I don't even see the first one. Yeah, this one here, 117. So they strike, and then they put it here. This is tedious. Imagine now we have to look for another one that's somewhere between 110 and 119. Where is that? It's easy to, as you move this way, it's easy to just skip one and not see it. You see, I don't even see another one. Yeah, I don't think there is, or maybe there is. But if you are doing what I showed at the beginning, that will be easy. So please ensure they don't do that. When a student gets to say 190 to 199, you notice they do this. They look to see 190 to 199. Where do you have a figure like that? Going all through the data to identify a number that's between that is a lot tedious and likely to introduce an error. So please, I caution you against having to use that, and please don't do that. Do what I have showed at the beginning there. And now as we progress, I need to show you what I did as I was preparing for this presentation. So I did the striking for you, and so there it is. I struck 165, it's somewhere there. I struck again and went all the way, and it was easy. I did not even make an error, and so I hope you find it helpful. Again, the tallies also got developed here. It's easy to notice the kind of the frequencies that we have, because you see, when you have 2 strokes, it means we only have 2 people. We have 2 times that the population of people in that train were somewhere between 110 and 119. Okay, when you have 3 here, it means there are 3 times when the population or the people in the trains were somewhere between 130 and 139. So you don't need to calculate that a lot. This will be 2, this will be 2, this will be 3, this is 6, this is 9, this is 8, 7, 8, 1, 1, 2, and that's right there. How do you find that helpful? I was considering that to be one of the major concepts that I want you to get, and so maybe now we move to the next thing. We have reduced the data to a frequency distribution table starting with classes of 10 to 110. With class intervals of 10 and starting with 110, and there it is. I need to mention that the class intervals in our case is 10. It doesn't look like 10, but it is. If you transform these to class limits and subtract the lower bound from the upper bound, or sorry, lower limit from the upper limit, it will be 10, and so it's actually right. I think we now move to estimating the mean number of passages of on a particular occasion. The mean would be just a sum of f of x divided by n. All right, where we use this table here. We had the classes, we developed the frequencies. Remember, we don't need the tallies here. We were using the tallies to help us make sense out of the data, and so we don't need it here. I've not included it. But if you are doing this question for an exam, you just need to add these other columns just next there. You don't need to develop another table. So we have the classes, we have the frequencies, and the midpoints. The midpoints is just averages of these values, like 110 plus 119 divided by 2, you get this figure. 120 plus 129 divided by 2, you get that one. And all the way, because the class intervals is 10, just to get the next one, you can always be adding 10. So 114 plus 5, 114.5 plus 10 is 124.5. Plus 10, 134.5. Plus 10, and on and on. The last one will be 214 plus 0.5, which is also 210 plus 219 divided by 2. Again, we need to have an f of x, which is the x's times the respective f's, frequencies times respective midpoints. So 2 times 114.5, it will be 229. 3 times 124.5 is 373.5. 3 times 134.5 is 403.5, and all the way. 2 times 214.5 will be 429, and again you add that, and the mean will be 8,105 divided by 50, and it will be 162.1. So that's the average that a train would be having on any given occasion using the data they were given at the beginning. Well, having said that, we move on to the next part. The question was, find the range of marks that would give us a middle 80%. It's a little tricky, and I'm going to use all sorts of things to explain, and let's begin. Now, assume that the data is arranged in ascending order like we have here in 100 small units. The total number of people here is, what was it? Yeah, it was 50. So assume that it's divided into 100 portions. If that was possible, that's a question. That's a concern. The 10th value, where the 10th value would be, between that 10th and the 91st value would have 80% of all values. Okay? Between the 10th and the 91st, between there, would have the 80% of all the values that we captured from the passengers in the train at any given time. If that makes sense to you. Okay? If I have, say, this 10 means we have 1 up to 9th value before that. This 91st means we have the 92nd up to 100th value after that. So somewhere between that, that is the 11th up to the 90th, they form the 80% middle, the range of marks. And so what do we need to do? To operate the question, we look for the 10th percentile and the 91st percentile. And I showed this, I think, in my second lesson on statistics. The tutorial is indicated statistics 2, so you can check it out. But just to fast forward, I need to mention that to operate anything to do with percentiles, we need to have another column there, so I have added it for you. We had the classes, we had the frequencies, we had the midpoints, we had the f of x's that we used to operate the mean, but now we need a class, cumulative frequency, sorry. So we have this one, and I explained in a previous lesson that this 2 is just this 2 here. This 5 is the same as 2 plus 3. This 8 is the same as 5 plus 3. This 14 is 8 plus 6, and 23 is 14 plus 9, all the way up to 50 is the same as 48 plus 2. So cumulative frequency, or frequencies given cumulatively. So we progress. The 10th percentile will be given by this particular value. You get the 10th percentile class, which will be 10 over 100 times 50, which is the 5th value, and it's right here. So we look for that particular class. The lower true class limit is this one, 119.5. So you get 120 minus 0.5. And again, the values are there. Cumulative frequency just before that is 2, which was actually the first one. Then the cumulative frequency, so the frequency of that particular class is 3, which is this 3 here. And again, the class width is 10. So putting the values, operating, the 10th percentile value will be 129. Remember, 129.5 means, 129.5 value means below it we have 10 values. Okay? And up to the 10th value, really. This is actually the 10th value. That means below it we have, I think I would say, 9 value. And above it we have, below it we have 9 values. And so this is the 10th value. Let me just put it that way. The 91st percentile will be given by this again, because we have 91 over 100 times 50, which gives us the 91st percentile class, which will be, I think this was, what was it? I think 45.5. Yes, 45.5. And where is that? It is about here. So the class is this class here. So the lower true class limit will be 179.5 minus yeah, just that, 175.5. The values there, the cumulative frequency just above that is 38. Yes, the frequency of that particular class is 8. You multiply by 10, which is class width, and getting operating the answer will be 188.875. So that's the 91st percentile. So the question was, what are the range of marks which give us the 8% of the middle 80% of all observations? So it will be somewhere between 129.5 and 188.875, and so this is the range of the middle 80%. It's a little tricky, but I hope you can follow. Again, that concept there really uses the question there really uses the concept of percentiles a lot, and a student should have good mastery of that. Well, I think we need to move to the next thing. Now, we are told the table below shows marks obtained by Form 4 class in a certain school, and they're given there. We are given the marks in classes. We have classes. Then we have density, the number of contents. I don't know what it was, but these would be our frequencies. So those who are between 8 and 9 were 2, between 9 and 11 were 6, and all that. So the question is, use that data to develop a histogram, okay, and use it to estimate median. And so we begin. The first thing I need to mention is that when we are doing a question on histogram, we always will need to have the classes at the end of the day, and those ones are always given. We'll also need to have height, and these ones are not given. All right. So my business here is to show you how to develop the heights, which we'll use to develop the histogram. But we cannot have the height unless we have the area. So let's begin with the area. Now, in the area, we normally say this, that frequency of any class is directly proportional to its area, or to area, okay? And so we have freedom of picking any of the classes and say, let that particular frequency represent a particular given area. You can say, let 2 be even 200. You can say, let 3 be 30. You can say, let 1 be 10. And remember, I'm picking numbers which are easy to operate, so that I'll eliminate having the possibility of getting decimals. So for my case, I say let 8, that's 8 values, f representing 8, let 8 represent 80 square units. Let 8 represent that. So the question will be, what about 2? If 8 is 80, the area is 80 here, what about 2? Notice that you just need to do a cross multiplication, and it means that you multiply this by 10. That means for every value of these f's here, to get the corresponding area, we'll just need to multiply the f times 10. So for our case, this will be 20, this will be 60, this will be 30, this here will be 20 and 10. And therefore, we are going to get the areas as I've said there. The next thing is the height. How do we get the height? Now, at the end of the day, we'll be drawing a histogram, which is actually bars, all right? A bar of some kind. And that means we will need, let me illustrate using a simple drawing, and I'm going to draw it here. We'll have histogram where we'll have, say, a column like that. I'll assume that's a rectangle. Maybe I'm not an artist, so you can see that. The area of this particular rectangle, assume the area is 20. Okay, assume the area of this particular rectangle is 20, and it has a class width of from 8 to 9 is just 1. This way it is 1. This distance here, it is 1. That distance is 1, and the height we don't know, but we know the area is 20. What will be the height? It'll just be 20 divided by 2. I think that's simple. So that gives us an easy way of finding the heights for every particular class. So what we normally do is we just get the area divided by the width. In this first class, let me mention the width. In the first class, the width is 1, because the class width, these are class limits, I need to mention that. The class width in this case is 9 minus 8. The other case there is 11 minus 9, which is 2. This one is 13 minus 11, which is 2. This is 16 minus 3, minus 13, which is 3. 20 minus 16, which is 4, and 21 minus 20, which is 1. So this class, these heights here will be given by the areas divided by the corresponding width. So for the first class, it will be 20 divided by 1, which is 20. The height will be 20. The next one will be 60 divided by 2, which is 30, and on and on. And so if you populate that, you're going to say that the areas will be 20, 30, 40, 10, and all that. You can operate that. You can always pause the video and calculate it to see if the values are right. I hope that's easy. Now, the next step is we are going to draw a histogram now. We're going to draw a histogram. And let me take you through that now. We have the classes which were given, and now we have the heights. So we're going to plot distance against this. There's not much I need to say there. And the diagram that we will need is this. Few comments though. On the x-axis, we have the upper true class limits. In our case, we'll have 9 11, 13, 16, 20, and 21. They are here 9, 11, 13, 16, 20, and 21. Notice that the class widths are not the same. The first class, the width was 1, the second one is 2, the second one was 2, the third one was 3, the next one was 4, and the last one was 1. Okay? And these are the frequency. In the y-axis, we have frequency density, which is now the heights. So the first class had a height of 20, it's right there. The second class had a height of 30, it's right there. All the way up to the last class having a height of 10. And I think that's easy to say. Ensure that your diagram looks like mine or something close to that. What was the next question? Estimate median. So we now go to that particular part. And so let me say this. We will need to look for a way of dividing the area of all the bars into two, such that if, say, the line we will draw along this particular class, we'll have a half the area this side, a half the area the other side. So basically, as we estimate the median, we look for where is that line? Where is that line that divides the areas, all the areas added together, divides into two. Now the total area was, we just add this 20 plus 60 plus 80 plus 30 plus the areas. You just add them. They are 220. Divide by 2, you get 110. So if we can have a line drawn such that we have an area of 110 square units before that and 110 square units after that, that line will be the median line. But where is it? What we do next, here is I have also drawn, I've tried to estimate for you there. We have the estimate of that line I was mentioning there. Now, 110 is somewhere after the sum of the first two. So I have 20, which is this area here, is 20 units. 60, which is the second one there. If I add the next one, I'll pass this 110. So what we normally do is we'll have the 110, you subtract the two classes which are close to, and they are full, but close to 110, but not after 110. So in our case, I'll have 110 minus 20 plus 60. 20 and 60. Why? Because if I add the third class, I'll pass 110. Remember, 20 plus 60 plus 80 will be, I think, 160. So I don't want to go past 110. I just need to go somewhere before 110, but to have full classes. So 110 minus the sum of those two, it'll be 30. So that means we have an area here between where the line is and 11. We have an area here which has an area. We have a region there whose area is 30 square units. We have a region there, the area is 30 square units. And the question is now, what is the width? We know the height of that particular class. It's given. It's 40. It's also here. It's a third class. The height is 40, but the area is 30. What about the width? Well, as I illustrated at the beginning, the width therefore will be just the area you divide by the height, because this is just the area of a rectangle of some sort. So we'd have 30 is equals to W times 40. So in that case, I'm going to say 30 is equals to 4 times W, in which case the W will be 0.75. So you're just dividing both sides by 40. So that tells us that median is 0.75 units after 11. And so what's median? Median will just be simple. It is 11 plus 0.75. And so it'll be 11.75. That's an estimate of the median. I actually think it's not an estimate. It's an actual calculation. And that brings us to the end of my presentation about some concept in statistics. Those two there about frequency distribution table and again the histogram. I hope you find it helpful. Always like, subscribe, and share. Thank you.